This is a promoting sustainability, renewable energy. A fuel cell is a device to produce electricity from chemicals, such as hydrogen and other fuels, which store energy in their molecular bonds. If hydrogen is used, a fuel cell produces only electricity, water, and heat. Fuel cells work like batteries. They do not run out as long as there is fuel supplied. A fuel cell consists of a negative electrode, also known as an anode, a positive electrode, known as a cathode, and an electrolyte in between. Chemical reactions occur on two electrodes to produce electricity and water. The electrolyte can carry electrical charge particles between the anode and cathode and make this chemical reaction occur faster. In a hydrogen fuel cell, hydrogen atoms will go into the anode and a chemical reaction will oxidize the hydrogen atoms by removing their electrons. Positively charged hydrogen ions and negative electrons are created at the anode site. The negative electrons create a current when they move. They move through the wire and then produce the electricity. The hydrogen ions are carried by the electrolyte and moved to the cathode. The oxygen atoms will go into the fuel cell as cathode, attaching to the positive hydrogen ions and producing water. This animation provides more explanation on this process. It shows the hydrogen moving from the tank, the negative electrons being removed, moving through the electrical circuit, the oxygen from the air, and the water going out of the exhaust. Fuel cells are classified primarily by the kind of electrolyte they use. Different electrolytes cause different electrochemical reactions that take place within the cell. Catalyst required, the temperature range, and the fuel required are varied. These applications of the fuel cells, therefore, are varied with different types of fuel cells. Each type of fuel cell has its own advantages, limitations, and potential applications. Some fuel cells work well for use in large-scale stationary power generation, while others may be suitable for using in vehicles or small portable devices. Some well-known fuel cells are alkaline, AFC, molten carbonate, MCFC, phosphoric acid, PAFC, proton exchange membrane, PEMFC, and solid oxide, SOFC. They all use hydrogen as a fuel to generate electricity. Again, fuel cells have been applied to a variety of devices or facilities, ranging from a utility power station to a laptop computer. Their applications include transportation, material handling, stationary, portable, and emergency backup power applications. Currently, many research and development efforts are taken in the application for vehicles. Some other applications. Here is a chart depicting the important components of a fuel cell car. As we spoke about, this car must contain an anode and a cathode. There is a membrane in between. You can see where the water comes out, the oxygen goes in, the charging from the electro engine, the power electronics, the batteries, as well as the hydrogen tank. Benefits over combustion-based technologies are currently used in many power plants and cars. They produce smaller quantities of greenhouse gases and no air pollutants that create smog and cause health problems. When pure hydrogen is used in a fuel, fuel cells emit only heat and water as a byproduct. Fuel cells do not require special disposal treatments required by batteries. Conventional internal combustion engines cost about $25 to $35 per kilowatt. A fuel cell system needs to cost about $30 per kilowatt in order to be competitive. Durability and reliability. The durability standard for automobiles is 150,000 miles under normal vehicle conditions. Reliability requirement is 40,000 hours of operation. This is only 7.5% effective when used with solar power. The size of fuel cells are also too big for easy use, and the oil economy is too big. These are all challenges that are faced while trying to improvise using fuel cells. Hydrogen production is another challenge of fuel cells. In order to produce hydrogen, energy is consumed. Sometimes, the electricity created in fuel cells could not compensate energy used to produce hydrogen. Currently, hydrogen is produced in several ways. For example, from natural gas through the reforming process, or from many other organic compounds like hydrocarbons, propane and gasoline. Hydrogen could be produced from water through an electrolyte process, in which it uses an electric current to split water into hydrogen and oxygen. The electricity needed to be generated can be using renewable energy technologies like solar, wind, geothermal, and hydropower. We believe using renewable energy is more promising in developed fuel cell technologies, but the scale is limited because of the efficiency is low when breaking water to produce hydrogen. Although facing many challenges, the global fuel cell market is expected to increase in the next 10 years. The Asian Pacific market region is now dominating fuel cell market with a revenue share of 58.78% in 2019. Fuel cells are being used from portable chargers, residential CHP, to vehicles and large-scale stationary power generation. The governments in the region are also strongly supporting and have provided subsidies, initiatives, and investments to businesses and manufacturers. As the low space requirement and high power efficiency, the stationary application dominated fuel cell market and will continue growing in this region.